Hello, everybody. Hope you're all having a great day. Welcome to the 108th episode of YFTT, Tech Talks for Engineers by Engineers. Today, we have with us Shikhar Sahay, who has been interning with us for almost a year. He joins us from BITS Goa. Shikhar is going to explain how to perform some typical day-to operations using our simple CLI-based service controller and configurator, YugabyteDB, which ships with YugabyteDB. Over to you, Shikhar.
Okay. Hi, everyone. My name is Shikhar, and I'm a software engineer at Yugabyte. And thanks, Prem, for the introduction. Let's get started with the topic for today. The topic today is running day-to operations with YugabyteDB open source software. The agenda today is understanding what YugabyteD is. Next, we are going to learn on how to deploy a multi-region cluster using YugabyteD. And finally, with that cluster in hand, we are going to run some day-to operations like leader pinning, backup restore, point-in-time recovery, and we are going to handle upgrades using YugabyteD. Now, YugabyteD makes it very easy
Shikhar.
for us. Yeah.
So we have an interesting question. So what is from Pavandeep? So what is the meaning of day two?
Okay, so you can consider day one as operations such as setting up the cluster. Now, setting up a multi-region cluster or a multi-zone cluster can be a day one operation where I just start my nodes on my machine. And after I start my nodes, then I run some day two operations. Day two operations are mainly around configuring the cluster. By configuring, I mean when I do leader pinning, we will see in the further demos how leader pinning is pinning all the tablet leaders to one region. So these are some day two operations which I do after running my day one operations, which is setting up the cluster.
Okay, let me speak a little few sentences here. So typically in software engineering, infrastructure management, these are classified as day zero operations, day one operations, and day two. Day zero is basically planning, design. Day one is where you actually install the software. But day two is what happens after you have your software system up and running. So all the operations that you do after your installation is over and you have it already running, but what steps, what process that you need to take actions. All right, go ahead.
Okay. So as we were talking about YugabyteD, YugabyteD is a very easy CLI tool for us to deploy, configure, and manage our YugabyteDB cluster. We'll be seeing in the demos more about YugabyteD. A little more introduction on YugabyteDB architecture. Since YugabyteDB acts as a two-server architecture with YB master service and YB T server service. The YB master service mostly managing the metadata, the YB T server service managing the app data. Now, handling them separately might become a little difficult and tedious for new users because there are a lot of commands and we have many flags to deal with. This is where YugabyteD comes into the picture, acting as a parent server across YB master and YB T server. A little more overview on YugabyteD. Now, YugabyteD is a daemon service, which means it is a background process. It runs in the background while it manages our YugabyteDB cluster. YugabyteDB supports multiple deployment strategies, like it supports a single AZ deployment, a multi-AZ deployment, a single region deployment, a multi-region deployment. YugabyteD also runs multiple prereq checks on the system before it starts a node. We also have a UI, which I'm going to show in some time, which helps us managing and monitoring the cluster. And finally, we have the YugabyteD service is GA with version 2.18, and it can also be used for production purposes. Now, let's learn how to deploy a multi-region cluster using YugabyteD. To deploy a multi-region cluster using YugabyteD, we start the first node by running YugabyteD start. Then we specify the cloud location flag. The cloud location flag takes in the cloud location of the first node. And then we specify the fault tolerance flag. Over here, we want a multi-region topology. That is why I'm giving the fault tolerance as region over here. Now, when I run this particular command, my first node gets started. I go to the second node. I start the second node by giving YugabyteD start. I again give the cloud location flag, which is the location of the second node. I give the fault tolerance flag. Now, when I start the second node, I specify the join flag. The join flag is going to take the IP address of the first node. And in this manner, the second node joins the first node, and we have a two-node cluster set up. Similarly, to start our third node, We again specify the cloud location flag and the fault tolerance flag, and then we again give the join flag with the IP address of the first node. Now when I run start command on all the 3 nodes, we have a quorum which is getting formed, and we have our multi-region cluster set up. Now,
All right.
after we have the
So
multi,
quick thing. So by default, fault tolerance is zone in YugabyteDB. So because Shikhar is setting up a multi-region cluster, he wants to set the fault tolerance to region. That's why he has to explicitly call the fault tolerance to be region. All right, go ahead.
correct. Okay. Now, after my cluster is set up, I have to run the configure data placement command. And since fault tolerance is region, I give the fault tolerance flag. The configure data placement command makes the data to be distributed across all the available regions for redundancy. After I run the configure data placement command, I should be getting a message which you guys can see over here. It says configuration successful, and the primary cluster can survive one region of failure, which is what we want. Now we run some critical data operations on YugabyteDB. Before that, I would like to go to my setup which I have. I've already set up a 3-node multi-region cluster. We can see that this is my first node over here. We'll be hitting the YugabyteDB UI to get more insights on the cluster. Currently, we have 3 nodes. This is my first node, my second node, and this is my third node. Let me hit the YugabyteDB UI endpoint. The port number for that is 15433. I can hit the endpoint. Okay. So this is the YugabyteDB UI we have. Let me go to the nodes page. Under the nodes page, I can see that I have my nodes set up. The first node I have is in US West 1B. My second node is in US Central 1C. My third node is in US East 4C. And this is a multi-region topology. Before we start any cluster operations, we have our in-house tool called Voyager, which is used to migrate data from one database to another database. Over here, I have migrated the account DB schema from an RDS database into our YugabyteDB. Just a quick overview on how Voyager migrates the data. It roughly uses around 3 or 4 steps. The first step is an export schema step. In export schema, we export the schema from our source database into the Voyager VM. And then we have the import schema step where we import the schema from Voyager VM to our target database. In that also, we analyze the schema. Voyager analyzes the schema, gives its recommendations on what changes or what modifications have to be made to the schema before we are importing the schema. So it goes like exporting schema, importing schema. Then we have export data step where we export the data from the source VM to the Voyager VM, and finally we import the data. Over here, I have migrated the account DB schema into our target database. We can see that the account DB schema has the following tables. It has the accounts table, it has positions table, and these are my tablets. This is the initial setup which I have. Okay, moving on. Let's go to our first operation. Our first operation is leader pinning. Leader pinning is a strategy through which users can assign a preference to different regions. Now, what happens when we assign preference to different regions is that based on this order of preference, a region is chosen, and tablet leaders, they move to the region which has been given the highest preference. Now, when all the tablet leaders, they move to a single region, what this does is it reduces the number of network hops for a write operation. This means the latency is reduced. Now, when all the tablet leaders, they migrate to one particular region, then all the write operations coming from the app, they can be directly acknowledged by all the tablet leaders which are present in that region which has been given the most preference. We will see with a diagram later on how this is happening. Before that, let's look at the syntax for setting preferred regions in YugabyteD. We have the configure data placement command. We have the constraint value flag. The constraint value flag, it takes in regions where we want the data to be duplicated to. Now, to set a preference for any of the regions, we specify the region name, we append a semicolon to it, and we give a numbering. The numbering is the priority numbering which we are going to give. It can be 1, 2, or 3. In this particular example, we have given a numbering of 1 to our first region. We do not have a preference over here for the second and third region. What happens with this is when the node hosted in the first region goes down, nodes present in region 2 and region 3, they become equally eligible to host the tablet leaders.
So the tablet leaders will be split across those two if in cases first one goes down, right?
That's correct.
Yeah.
Okay.
So
Now we
one
have,
thing, so leader pinning is also known as preferred leaders, preferred regions. So when you look up our docs, you will see all the three terms. Sorry about that. Yeah, go ahead.
no worries. Okay. Now this is a quick diagram illustrating leader pinning to us. We have three regions over here. We have US West 1, we have US East 2, we have US Central 1. We can see we have nodes in all the three regions. Now the tablet leaders are indicated by solid lines. And now we can see that we have first tablet leader over here. We have one tablet leader in US East 2 and one tablet leader in US West 1. Initially, they are equally distributed across all the regions. My app is running in US East 2. What I'm going to do is I'm going to pin the leader to US East 2. We can see that all the tablet leaders indicated by solid lines, they have migrated to US East 2 from US Central 1 and US West 1. And now all the write operations coming from the app now will be directly acknowledged by all the nodes which are hosting the tablet leaders in US East 2.
Okay, could you go over that slide, previous slide? Okay, so as Shikhar explained, the primary reason why you have to do leader pinning is that when a write operation happens in Yugabyte, has to be acknowledged by at least one other replica. Now, if you place the one of the replicas, and so the other thing that he has not noted is the replica here in US East 2 after leader pinning is also located in US East 2. So immediately it will be acknowledged, and that is for the write. For the reads, if the reads span multiple tablets, when you don't have leader pinning, it will go across multiple regions. That is why the leader pinning is very useful, because when you have leaders pinned to a specific region, all your reads will actually be responded from a single region, and the inter-tablet, inter-zone latency will be very, very low.
Okay. Now we have a leader pinning demo that I'll demonstrate using Yugabyte. Before that, I would like to show my point that the accounts table, the tablet leaders which it has, is currently it is distributed across all the nodes, and we have seen that all the nodes are present in different regions. So I'll be giving preference to one of the regions so that all the tablet leaders can migrate to that particular region. Now for doing that, we have already understood this command which helps us do leader pinning. I'm going to run this command on our terminal. We can see that over here, I have given the first preference to US West 1B. Second preference has been given to US East 4C, and third preference has been given to US Central 1C, which is also what comes up in our status message. Now we will be hitting the UI again. We go to the notes page. We can see that US West 1B has now been given a preference of 1, which is where the first node is residing. US Central 1C has been given the third preference, and US East 4C has been given the second preference. Now let me quickly navigate into the tablets and see how the tablets have migrated. We can see that all the tablets, they're now hosted by the leader node, which is 10.150.5.95, which was present in our preferred region, that was US West 1B.
Could you show that? Yeah, 195 1B. So the other advantage of leader pinning is that once you have a proper preference set, if you use our YugabyteDB smart driver and then give the topology case with the same preference, when a region fails, your app will automatically switch over to the region without any need for external load balancers. So.
Okay. This is the same case for all the tables. We have the tablet leaders present in the first node. So this was a demonstration on leader pinning. Let me go back to the slides. Okay. The next functionality we have, the next day 2 operation we have is backup restore. Backup restore is used at the times of disaster recovery. The core concept behind taking a backup is to create a snapshot of the database, and then we export it to the desired location. The desired location over here is specified by the cloud storage URI flag. We will be seeing the syntax on how to do this in Yugabyte in the next slide. But just for information, cloud storage URI flag, it can take in a local Linux directory, an S3 bucket, or a GCP storage. As I told before, we have the syntax for backup. It goes like YugabyteDB backup. We give the cloud storage URI flag. This can take in an S3 bucket or maybe a local Linux directory. Then we have the database flag. Under this, we specify the name of the database that has to be backed up. And now we have backed up a database. We want to restore that. To restore, we have a similar command structure for restoring. We again have the cloud storage URI flag. We have the database flag. We specify the name of the database that has to be restored. A quick point: before running the backup and restore commands, YugabyteD should be started with backup daemon flag set to true. What happens when we set the backup daemon flag to true is it starts background agents that are actually necessary for taking a backup or taking a restore. This is a high-level diagram illustrating backup restore in YugabyteDB in general. We have cluster A, we have cluster B. We take a snapshot, we send the backup to an S3 bucket, which is specified by the cloud storage URI flag, and the cluster B, it can restore that particular backup into its system. Next, we have a backup restore demo in YugabyteD. Firstly, I'm going to run a backup for the database which we had migrated using Voyager. When I run a backup, as we have discussed before, it says backup command, cloud storage flag. We give the location of the S3 bucket. Then we, under the database flag, we provide the database which we want to back up. Over here, we want to back up the target database. Let me quickly check the status. To check the status, we can use the same command and append the status flag to it. When we append the status flag to it, we can see that a backup is in progress and it takes some time for the backup. Meanwhile, what I'm going to do is we have another, just a second, yeah. We have a single node cluster that I had started before, and I had already taken a backup to the YugabteDemo Northwind database in our single node cluster, which I started before. What I'm going to do is I'll be taking a restore of this backed up database into our 3-node multi-region cluster. Over here, I can see that YugabteDemo Northwind is absent in our 3-node multi-region cluster. It is present as a backup in our single node cluster. For that, we have the restore command. I'll be running the restore command now. I run the restore command. It says restore started successfully. Before that, let's check the status of the backup. It says backup is complete. We also show this in our UI. Let me quickly refresh it. Under databases, we have the backups tab. We can see that under backups tab, we have the backups tab again. And we can see that target database has been backed up. And let's now check the restore status. To check the restore status, we again use the same command. We append the status flag to it. Let's wait for some time before the status message comes up. It says the restore is in progress. Let's check again. It says restore is in progress. Let's wait for some time before the restore is done. Okay, the restore is complete. Since the restore is complete, let's go to the restore tab. We can see that we have successfully restored YugabteDemo Northwind from our single node cluster to our 3-node cluster. And when I check the databases tab, I can see that the YugabteDemo Northwind has come up. Since it has come up, we should be able to connect to YugabteDemo Northwind. Now this is the connect YSQL command. We have the database flag with it to directly connect to YugabteDemo Northwind database. Let's do that. Now we are able to connect to the YugabteDemo Northwind database because we have restored it. We have /D command, which helps us list all the tables which are present as part of YugabteDemo Northwind database. We can see that we have a bunch of tables. And yep, this was the backup restore demo. Let's go to our next operation.
Hey, we have one question, Shikhar. We have one question.
Yeah.
So from Jim Nicely, our own SE, and he's asking, are incremental backups supported with YugabyteD?
Currently not. Currently, we don't have incremental backups. These are just taking snapshots and exporting it. But yeah, in future, we are planning to introduce incremental backups to YugabyteD.
Awesome.
Okay. So the third operation we have is point-in-time recovery. Now PITR, like backup restore, is used at times of disaster recovery. We can be using PITR in 3 of the cases. We have DDL errors, that is such as we remove a table accidentally, or a schema changes because you run a workload and that workload abrupts your database maybe. And then we have DML errors, such as a record is incorrectly updated or a column is added which you don't want. So in such cases, we can use the PITR functionality to get our database stored to a desirable state. Now, PITR is basically a combination of two processes. We take distributed snapshots, and then we have something called as flashbacks. I'll explain you what flashbacks are using this diagram. Let's take a look at this diagram. This diagram has 3 points. We have point 1, we have point 2, we have point 3. We take snapshots at point 1, we take snapshot at point 2, we take a snapshot at point 3. Say after point 3, the user realizes that he has accidentally dropped a table and the user wants the table back. So he has to use PITR functionality to get his database back to a desirable state. Now the user knows that between point 2 and point 3, there was a state where the database was consistent and had the table with him. Now what he can do is he can run PITR. PITR will restore his database back to point 3 because we had a snapshot at point 3. And now what happens is the write-ahead log files are read and the transactions are reverted, and the database can be restored to a particular point, to a desired point wherever the user intends to restore his database back to.
So,
Yeah.
so do we? What level of accuracy that you give as a precision? Seconds or milliseconds? How does that work?
So in YugabyteD, it is in seconds, but if you go to the code DB, it is in milliseconds. But
Okay.
because of some design ideas, we had made it to seconds. Yeah, so it is in seconds
Nice.
as per YugabyteD.
Sounds good.
Okay. Now again, a demo for PITR we have.
Hey, so another question from Ani.
Hi.
Ani, so what's the minimum time window for each snapshot?
Okay, I'll just explain it using the commands. I'll get this point over there.
Oh, he's coming to it, Ani. So hang in there.
Yeah, I'll come to it. Yeah. Okay. So first, what I'll do is I'll enable PITR on the YB demo Northwind, which we had restored. Now coming back to the question, so we have a retention flag. Retention flag over here, it takes in the number of days. Now these number of days over here we have 3 days. That means the snapshots are retained for a period of 3 days. And our interval by default in YugabyteD is 24 hours. That means after each day, a snapshot will be taken and that snapshot will be retained for 3 days. And I'll answer the question better with the next command which I have. So we have the status flag as part of point in time recovery. What happens with this is we can see that point in time recovery has been enabled for YB demo Northwind, and we also give out the earliest recoverable time. Now this is the time after which we can restore the database to. That means between the current time and this particular time, the database can be restored. So I hope that was the question that was asked.
Minimum time window for each snapshot. Probably he meant 24 hours.
Okay.
Ani, could you clarify the question? All right, I think you have answered both the variations. So
Yeah. Okay.
Cool. Go ahead.
Okay. Now we can check the UI. We also display in the UI whether PITR has been enabled or not. We can see that PITR has been enabled for YB demo Northwind database. You can see interval is specified over here, retention is specified, recoverable time is specified. So our users can check the UI to see if PITR has been enabled or not. And the next thing I'm going to do is I'll connect to...
Before you go ahead, so Ani has clarified. So one more follow-up question. Can we go below 24 hours?
No, we can go below 24 hours as part of CodeDB, but in YugabyteD, because to be consistent with the YBA functionality, we have specified 24 hours as the interval time, and that is totally fine because we have snapshots that is being taken 1 day after each day.
So what Shikhar is saying is, as of now, we have explicitly made it 24 hours, but we are working on a feature to extend this to make it more versatile. So that your users will be able to configure exactly how often the interval of snapshots could be.
Yep. Okay. Should I go ahead?
Yeah, go ahead.
Okay. So firstly, I'll connect to YSQL. I'll connect to YB demo Northwind. And okay. Now I'll list the tables. We can see we have a bunch of tables. We have the categories table. Let me just query from this category tables to show you guys that oops. to show you guys that we have some data over here. We can see that I've just queried 5 rows from categories table. Now what I'm going to do is I'll I'll drop this categories table. Say user accidentally drops a table over here, I'm purposely dropping it. Now let's drop the categories table. Let's just query from the categories table again. It says categories table does not exist because we have just dropped it. Now the user realizes that, okay, his categories table is now absent and he wants the categories table back. What he can do is he can run PITR. And since he knows that at this particular time, that is the earliest recoverable time, he knows for sure that at this time, he had the database in a desired state. He had the categories table back with him. So what I'm going to do is I'll restore the database back to exactly this time and check if the categories table is present with us or not. So let me run the restore command. The restore command will restore the database for us. Let me change the time. The time will be the earliest recoverable time because this is a desired time. Let's run PITR. A successful message saying recovery point is the earliest recoverable time over here, and database for YugabteDB demo Northwood, we have run the restore. Now the database has been restored to the
That was
desired
fast.
state.
That was very quick. Is it a small database? How big was the database?
We can actually take a look at how big the database is.
Oh,
Actually,
that's it.
PITR is a very quick operation. Even if the database is big, it hardly takes more than 5 to 10 seconds for PITR to run. It is a very
Nice.
lightweight operation. Okay.
Nice.
Okay. Now let me just connect back to the database. I'll connect back to the database. I'll list the tables. Okay, we can see that the categories table is back with us now. Let me just query from the categories table to see if our data was safe. Now I query the categories table. I see that the data which was previously shown.
We should have done a
shown this.
we should have done a count star rather than limit 5. But anyway, that's fine. That's okay.
Okay, yeah.
All right.
Okay. So we have the database back to a desired state. So this was PITR.
All right.
Okay. Do we have time for demo for upgrades?
Yeah, we have only 2 more minutes. We will quickly just skip the demo. Let's just talk about it.
Okay. Got it. Now the final operation which we have is handling upgrades using YugabyteDB. Now upgrades in YugabyteDB in general, they happen in place. What I mean by in place is that they happen in a rolling upgrade fashion, which means each node is upgraded one at a time, and the cluster is always up and online during the time of an upgrade. So any workloads which are running can still be running while the upgrade is happening because this is a rolling upgrade. And the steps that are required for an upgrade with YugabyteDB is, say we have a 3-node cluster in version V1. We want the cluster to get upgraded to version V2. What we have to do is we go to the first node, we stop that node in version V1, we change the binary to version V2, we restart the node to version V2, and we do the same thing for the second node. We stop the node in version V1, we change the binary to version V2, we restart the node, and after this exercise is done for all the 3 nodes, and we should be seeing that the node is now in version V2. Now, to finalize the upgrade, we have the YugabyteDB finalize upgrade command. This completes the post-upgrade tasks. The post-upgrade tasks are promoting the auto flags and upgrading the YSQL system catalog, which can be achieved by running our YugabyteDB finalize upgrade command. Since we don't have much time, we'll just skip the demo.
Can you do it in quickly in 2 minutes? Let's do it. Because
Demo?
I don't think we can have another session. Let's just do it. Yeah.
Okay. So this is, we have over here is a fresh 3-node cluster. We have 3 nodes over here. Now, as we had discussed that I'll stop the first node. I stop the node. I change the binary to, I have the node in 2.21 version actually before. I change the version to 2.23. Now what I have to do is I have to restart this. I'll just do a start command. The node gets started again. I have to just repeat this step again for the second node, and I have to now change the binary, and I'll run the YugabyteD start. Now, one thing, just pointing it out, say I prematurely run the finalize upgrade command. Over here, I've just upgraded 2 nodes and I have to upgrade the third node. But say prematurely, I run the finalize upgrade command. What will happen is we'll get an error saying version compatibility verification failed, because our third node, which is this particular node, it is still present in version 2.21. The error message says that we have to upgrade this node to version 2.23, and then we have to rerun the finalize upgrade command. So let's do as the error message has suggested us, that we stop this node, we change the binary, and we start the node again. Okay, let's go to the UI for this particular cluster. We can now see that the database version is 2.23, and since the database version is 2.23, let's run the finalize upgrade command. We can see that after we run the finalize upgrade command, we have the message saying promoted auto flags, a YSQL system catalog gets upgraded, and the post upgrade tasks are successful, and we have now successfully upgraded the cluster to version 2.23.
Awesome. Thanks. You can stop at that. And we have one final question from Greg from Fidelity. So, hey, for reviewing Yugabyte DB node overall monitoring performance and top SQL reviews, besides Yugabyte DB console, can we get some reports generated, like, for example, PG Badger? Want to be able to review for past given time frames, etc. So maybe I'll take that up. And so we have a lot of monitoring. You can check out our section on observability and in our docs. But we make sure that all our log lines are very close to Postgres logging format. So you should be able to use PG Badger to run against all the logs from the different nodes. It's just that we don't automatically collect all the logs from the different nodes. So you might have to run it against each of the node. But if you use our YB support tool, that will actually help you grab all the logs from the different machines together, and you should be able to run PG Badger on those logs. That's it. I don't think we have any questions. So I just want to say one more thing. So what Shikhar has demoed here is YugabyteD command line tool. So you had here, he showed us the different commands that can be executed using that. But for those who don't want to use command line interfaces, we have another product called YB Anywhere, YBA we call it, which has a very neat UI. And all the commands, all the functionality that he demoed today is just a button click away. You should try that out. All right, so we'll wait for a few more questions, and over to you, Shikhar. Nice demo.
Okay, the one last thing which I have is, so YugabyteD, we can see that all the 4 demos which I have done can be done just by running a single command. So the idea was to show that just by running a single command, we can do such complex critical operations so simply with using YugabyteD. So that was the motive behind showing the demos. And we can also check out the YugabyteD docs. It is present in YugabyteDB. You can go to the references, and then we have a YugabyteD section where all the commands are present, and you can play around with the tool yourself.
All right, thank you. Yep. Maybe we'll hang on for a very good presentation. Thanks, Shikhar. We'll hang on for like one or 2 more minutes, and then we can call it a day. All right. Greg, I hope I answered your question. So, Jim has asked, which version of YugabyteD was demoed today?
So this was the version 2.23.
Version 2.23 of YugabyteD?
YugabyteDB, yes, correct. I don't think we have, this is a build which I've taken. So we'll be releasing 2.23 in some time, I think. Currently 2.21 is available for global downloads.
Okay. All right, folks, so it's 10:05. We are already 5 minutes over time. Thank you. Thanks for coming to YFTT. Hope you all have a great day.